Today, we are diving into a paper that makes one of the absolute boldest claims in the history of science. We're talking about a complete solution to a legendary physics problem and, just maybe, a theory of everything.
You know, Albert Einstein once said, the most incomprehensible thing about the universe is that it is comprehensible. And that's really the driving force behind all the physics, isn't it? This deep-seated belief that for all its wild complexity, nature should, at its core, be simple. It should be elegant. It's all about the hunt for that one master key that unlocks all of reality. And then a paper drops. Dated October 31st, 2025, a physicist named Brandon Lee Friend claims he's found that key. Now, he's not just proposing some new idea. He claims to have flat-out solved one of the hardest problems in all of mathematics, and in doing so, unified all of physics. It's a huge claim.
So, before we can even begin to unpack the answer, we've got to wrap our heads around the question. And trust me, this isn't just any old question. It's one of the world's great million-dollar math problems.
Okay, so the Yang-Mills problem is really two giant questions rolled into one. It's all about the strong nuclear force. That's the stuff that literally glues the hearts of atoms together. First, the existence part. Is the math we're using to describe this force even, well, real? Does it hold up on a fundamental level? And second, the mass gap mystery. Why do the particles that carry this force, they're called gluons, act like they have mass when all of our best theories scream that they should be completely massless? It's a massive contradiction right at the heart of physics.
And just to give you a little context for how big a deal this is, the Clay Mathematics Institute put this problem on its list of 7 Millennium Prize problems. These are the hardest, most important unsolved questions in mathematics. If you solve it, you don't just get eternal bragging rights, you literally get $1 million.
So that's the formidable problem. Now, let's talk about the proposed solution. It's a completely new way of looking at the universe, and it's called quantum resonance theory, or QRT for short. And this is the core shift in thinking. The old view, right, is that the universe is made of all these separate little building blocks, particles, forces, and the whole puzzle is figuring out how they all fit together. QRT just flips that entire idea on its head. It says there's only one fundamental thing, space-time itself. And everything else we see, every particle, every force, is just a different vibration, a different note being played on that one universal instrument.
The whole theory really boils down to 3 simple rules. First, harmonic unification. Everything is just a different vibration of space-time. Simple as that. Second, mode-specific properties. The specific shape of that vibration is what makes it look like a photon or an electron or whatever. And third, quantum constraints. These vibrations still have to play by the established rules of quantum mechanics.
So this is all a really cool idea, this music of space-time. But how does it solve that super confusing mass gap problem? Where does a supposedly massless particle get its mass from?
Well, QRT proposes this really elegant process it calls the resonant self-trapping mechanism. It works like this. When a gluon pops into existence, its field creates a little dip in space-time, like a little gravity well. That well then pulls the gluon back in on itself. It's a feedback loop. The gluon basically digs a hole and then immediately falls into it, trapping itself in this tiny little bubble of its own creation.
And here's the absolute crucial point. Mass isn't something the gluon has, it's something that emerges. All that energy it takes for the gluon to stay trapped inside its own little bubble, that energy, thanks to Einstein's famous E equals mc squared, is what we perceive as its mass. So the mass gap, it's simply the price of admission, the minimum energy cost to create one of these self-trapped particles.
Okay, and this is the moment where a cool idea turns into actual testable science. Using nothing but its own core rules, QRT calculates a precise value for this mass gap, and the number it spits out is 1.7.
So, how does that number compare to reality? Well, our best estimates actually come from these giant supercomputer simulations that try to model the strong force. And they predict that a glue ball, a particle made of pure strong force, should have a mass of around 1.71. So QRT's prediction of 1.7, it's not just in the ballpark, it's a direct hit. It lands perfectly inside the experimentally predicted range.
But here's the thing. Solving the Yang-Mills problem is just the beginning. The paper argues that this theory's ambition is way, way bigger. We're talking about describing everything with a single equation.
Now don't let all the symbols scare you. You do not need to understand the math to get the absolutely revolutionary idea here. This one single line is being proposed as the master equation for all of physics.
Think of those little Greek letters alpha and beta as tuning dials. One dial controls how much a vibration traps itself, and the other controls how much it curves spacetime. And depending on how you set those dials, the equation describes completely different things.
Let me show you how it works. If you turn both the self-trapping dial and the curvature dial all the way down to 0, boom, the equation describes a photon, a particle of light. But if you crank both of those dials way up, you get a gluon, the trapped, massive particle of the strong force. Turn self-trapping off but allow for curvature, you get a graviton, the particle of gravity. The claim is that every fundamental particle we've ever discovered just pops out of this one equation with different settings.
So, let's just step back for a second. If this theory holds up, what does it actually mean for how we see the universe? I mean, it would require a fundamental shift in our entire view of reality itself.
For the last 100 years, physics has treated particles as the fundamental building blocks of everything. They are the little things that exist on the stage we call spacetime. QRT flips that completely. It says there's only one fundamental thing, spacetime. Particles aren't in spacetime, particles are spacetime, just vibrating. They're not objects, they're patterns.
The paper actually includes this quote from Isaac Newton, and it just captures the spirit of this whole thing perfectly. Nature is pleased with simplicity, and nature is no dummy. The idea that all the mind-boggling complexity of our universe could bubble up from one single simple, elegant equation, well, that's been the ultimate dream of physics from the very beginning.
So, if this theory is right, what is reality? It's not a machine made of a bunch of tiny parts. It's music. A symphony being played on the very fabric of spacetime, and everything we see, the stars, the planets, you, me, we're all just different notes in one grand cosmic composition.